Part B, we are talking about rational functions. What does it mean, rational functions? When we talk about rational functions, it means the fractions. I have a fraction as a function and I need to draw it. We will start first with the simple functions, and then later on we'll move to some more complicated functions. First, when I say rational functions, it means the form of f of x over g of x. And we know that a fraction is defined when the denominator is not equal to zero. Guys, when you are working with any function, fraction, radical, later on we're going to work with ln, you are not allowed to work with it if you didn't mention the domain of definition, because you need to see where are you working, in which domain are you working, because sometimes not all the values of x are acceptable. So the most important step when you are studying any function is to do the domain first. So the domain is very important. It's much more important than the range, because later on when you graph it, you will see the range. But the domain of definition is very important to do it in the beginning. So the numerator and the denominator of the rational function are polynomials. Polynomials, what does it mean? It could be degree 2, degree 1, degree 3. It could be a constant. You know that axn plus bxn minus 1, and we goes on till plus c. Now we will do first the reciprocal function. It's y is equal 1 over x. If I look at this function 1 over x, when I want to look at find the domain of definition, the domain of a fraction is defined when the denominator is not equal to 0. So what is my denominator here? It's x. I say x is not equal to 0. What does it mean x is not equal to 0? It means if I replace x by 0, can I have a value of y for it? 1 over 0 is undefined, and later on you will see that number over 0 is infinity. So as I'm saying that x is a bomb, I cannot step on it. But if there is a bomb somewhere, can I turn around this bomb? Yes, I can turn around it. And when I say x equal to 0, x equal to 0 is not just a point. X equal to 0, it's a line. Because when I'm on the orthonormal system, where are the points on this orthonormal system where x is 0? All the points on the one y-axis, all those points here, their x is 0. So x is equal to 0 is not just one point. X equal to 0 is a line. What this line is vertical. So it means x equal to a number, it's a vertical. What do we call it? It's a vertical asymptote. What does it mean, asymptote? It means that the function will approach to it. You can go near it, but you cannot step on it. It's a bomb. You can go around it from this side, or from this side, or from this side, or from this side, but you cannot, but you can approach to it till the maximum, but you cannot step on it because it's a bomb. And also, I have something called a horizontal asymptote. Horizontal, it's come from the word horizon, so it's like this. And the same, if there is a value of y that it's undefined, the function is undefined, this value we will call it horizontal asymptote. It's a bomb. I can approach to it, but I cannot step on it. So how we find the horizontal asymptote, how do we find the range, is by solving for y we will see in the example. So let's do the vertical and the horizontal in the first function here. When I say y equal to, I already did the vertical asymptote. How you find it? Denominator not equal to 0. To find the horizontal asymptote, I need to solve for y. It means I need to solve for x, I should say, not solve for y. Oh, God. Sorry, guys. It's solve for x, not solve for y. So I need to find x is equal to what? And then I need to find, as I'm saying, the domain of this expression. So x, y is equal 1 over x. What's going to be x is equal 1 over y? So y cannot be equal to 0 now. So it means the range is all the values of y except 0. So I can have all the answer except 0. What do we call y equal to 0? It's called the horizontal asymptote. And if you plot 1 over x on the graph, if you plot it, so let's tell you how to plot it. I need to draw x equal to 0. I have it here. It's a vertical asymptote. Y equal to 0 is a horizontal asymptote. And you can draw it by taking points. I already did it, but you can just take points and replace and graph it. Let's change the color. Okay, if I replace x by 1, y is 1. If I replace x by 2, y is half. If I replace x by minus 1, y is minus 1. If I replace x by minus 2, minus half. So 1 gives me 1. This is a point. 2 gives me half. and then this is the first part. If I go to the negative part, minus 1 gives me minus 1, minus 2 gives me minus half, and then I can graph it. This graph is called a rectangular hyperbola, or also we can say it's a hyperbola. So hyperbola, all the time I have one vertical, one horizontal, and either one graph here, another here, or here, or here. So you will see it later with all the example that I will do. Now let's do, guys, the first example. Given y is equal to over 1 minus x. Also, I can write it like this, guys. F of x is equal 2 over 1. It's a function of x. If it was here t, I write f of t is equal to over 1 minus t. It's not all the time x. But now we are using the letters x and y. How do we find the domain and the range of this function? So to find the domain of this function, I need to take denominator not equal to 0. Excellent. So if x is equal to 1, if I replace it here by 1, I'll have 2 over 0. It's undefined. So x shouldn't be equal to 1. So my domain is, you can write either x belongs to, or you can write df is equal, and you have the interval as you like. So it's all the values of x are accepted except 1. So I write it minus infinity 1 union 1 plus infinity. How are we going to find the range? To find the range, you need to solve for x. So I need to write it x is equal, and then you will do the denominator not equal to 0. So if you cross multiply here, guys, you're going to have 2 is equal y times 1, y, 2 is equal y times 1 minus x. And then I will have 2 over y is equal to 1 minus x. I need to solve for x. So I need to find x is equal to what? So I will have x is equal to 1 over minus 2y. Which value of y is not accepted? It's for y shouldn't be equal to 0. It means, what is my range? My range is minus infinity 0 union 0 plus infinity. From the domain and the range, I can deduce the vertical asymptote and the horizontal asymptote. So my vertical asymptote is x equal to 1. My horizontal is y is equal to 0. And then I will be able to draw my graph by taking points to graph it. So let's graph it. So I did already all the time. We draw first the asymptote. This is x equal 1. This is the point x1. This one is called the vertical asymptote. This one is called the horizontal asymptote. So the x prime or x represent y equal to 0, because any point, some students are always time confused. They think when I say y equal to 0, it's a y prime or y because the same letter. No, y equal to 0 because any point on x prime or x has y 0. That's why the equation y equal to 0 represents the x prime or x, and this is the vertical asymptote. Now I need to take some points just to know I'm in which area I will draw, here or here, here or here. So I will start by, if you take x 0, y is 2, so this is a point. Even if you take, for example, x minus 1, you will have here 2 over 3, so I'm in the positive part. So the first part of my function is in this area here, and this is the asymptote. You see, I cannot touch it, but I can approach to the asymptote. And I can take another point in the other areas. All the time you take some points before the vertical and after the vertical. For x equal to 2, y is equal minus 2, so I'm here. I can take for x equal to 3, for example. And it will be minus 1. If you take 3, it's gonna be 2 over 1 minus 2 over minus, it's minus 1. So I have, look, 2 points. So then the second part of my function is here, and then this is my function. So this graph represents the function y is equal to over 1 minus x. Let's do one more example. So I have now this function. Find the domain and the range of y is equal to x minus 1 over 1 minus 3x. Then deduce the asymptotes and confirm your answer graphically. It means I need to draw it and see if everything is right. So as we said, domain easy, denominator not equal to 0. 1 minus 3x not equal to 0 gives me x not equal to 1 over 3. Directly, you can deduce that this is my vertical asymptote. So x equal 1 over 3 is my vertical asymptote. How can I write the domain of definition? I can write it as an interval, or I can write x belongs to r minus 1 over 3, but I prefer to write it as an interval. So I can deduce directly the vertical asymptote from my domain. How are we going to find the range? We're going to solve for x. So we'll change it and write it in the form of x is equal to an expression in terms of y. Now I will cross multiply. I will have y minus 3xy is equal to x minus 1. My objective is to write x is equal. So I will isolate the variables. I will write x alone in one part and y in the other part. So this here there is x, here there is x. So minus 3xy minus 2x is equal minus 1 minus y. I need the x, I will factorize by here. I have a common factor minus x. Factor of 3y plus 2 is equal minus 1 minus y. You can multiply it all by minus 1 if you want. So you will have the other part becomes 1 plus y. And what will be x? X is equal 1 plus y over 3y plus 2. So how are we going to find the range? We're going to do the denominator in terms of y not equal to 0. So 3y plus 2 not equal to 0 gives me as y not equal to minus 2 over 3. So what is my range? It's minus infinity minus 2 over 3 union minus 2 over 3 plus infinity. And then I have now my horizontal asymptote is minus 2 over 3. How are we going to draw it? I draw the vertical, the horizontal, then take points to graph it. So this is my graph here. This is my vertical aspect equal 1 over 3. This is my horizontal asymptote y equal minus 2 over 3. I can take a point n bigger than the vertical and a point less than the vertical asymptote. For x is 0, what will be y? It will be minus 1. So for x is 0, y is 1. So this is a point here. Do you see it here? It's less than the vertical asymptote. So I know that my first part gonna be here. So it's here. Then it's a vertical asymptote. So I'm gonna approach to it, but I cannot touch it. Now, for x is equal to half, y is equal to 0, so at some point I can take x1, I can take x2, and it will be here somewhere here, and I can take even little bit less than half, but because the values are very small, so I cannot be really 100% accurate. And then I will graph it, and that's it. This is my graph, and I can check that. Let's check the domain. What does mean domain? The values of x. What are all the possible values of x? Look, guys, you can take all those possible values minus infinity, everything till I will stop here. Can I have x equal 1 over 3? No, so it's minus infinity 1 over 3. Excellent. Union, now I after 1 over 3, 1 over 3 plus infinity, so my domain is right. Let's check if my range is right. My range, I go for y. I'm starting from minus infinity, and I will reach till here, and I will stop. I cannot. Can I have minus 2 over 3? No. So it's minus infinity minus 2 over 3. Union now. I will jump here. I'm here now. It's minus 2 over 3 plus infinity. So I can confirm that the domain, my domain, and the range are right. So I didn't do any mistake with the domain and range. All the time, they should be linked to each other, and I should have the same answer by connecting the graph to my algebraically work. That's it for this part. So we'll see you in another video in the second part.